Hello, everyone. A very good afternoon. I would like to thank you all for joining us today. My name is Aparna, and I'll be hosting this webinar. Before we get started, please let me take a few minutes to introduce Payatu. Payatu is a research-powered cybersecurity consulting firm with a decade-long track record with a singular focus on cybersecurity. The foundation of Payatu rests upon three pillars: community and conferences, consulting and training, products. Community and conferences encompass an international security conference training and exhibition platform, and Hardware.io, a hardware security focused conference along with other initiatives. Consulting and training focuses on thorough security assessments, which helps businesses to discover security threats and further provide training to strengthen network infrastructure. Lastly, we have four offerings: IoT Auditor, an IoT security testing and compliance platform; Exploity, an open source IoT security testing framework; Exploity Academy, a comprehensive online learning platform that empowers professionals with the knowledge and skills to excel in the field of cybersecurity, particularly in the context of securing IoT devices; CloudFirst, an automated and highly scalable first testing platform. Here is an overview of the various consulting assessments we are known for across the globe. Payatu has delivered many cyber talks and workshops in top security conferences that include Black Hat and DEFCON. We take pride in the decade-long impact we have created by contributing to the cybersecurity community all around the world. As part of our ongoing commitment to fostering knowledge sharing and collaboration in the cybersecurity realm, Payatu has launched an exciting initiative, the Payatu WhatsApp community. The community aims to educate various organizations with industry-specific cybersecurity content. That was all about Payatu. Today, Akshay, Payatu's security consultant, will deliver a webinar on OWASP Mobile Top 10 Risks. You can read all about him on this slide. Before I hand it over to Akshay, I request you all to follow a few housekeeping tips. Please be on mute. If you have a question, you can write it in the chat box. We'll answer it at the end of the webinar. We will be releasing the recording of the webinar on our digital channel, so make sure you are following Payatu. If you are not currently following Payatu, please check the links provided in the chat box to find Payatu's digital channels. Without further ado, let's get started. Akshay, over to you.
Thanks, Aparna. Okay, welcome everyone to today's webinar. My name is Akshay, and we'll be discussing the topic OWASP Mobile Top 10 Risks that was released in late 2023, or officially it's 2024. So we'll take a look at the mobile top 10 risks today. Let's get started with it. Before heading to the agenda, a few lines about me. I'm a security consultant at Payatu. I've been here since over a year, and I have an overall experience of about 4 years in the InfoSec industry. I've mostly worked in pen testing applications, web applications, Android applications, API security. I also have some familiarity with cloud security configurations and policies. And I've also helped several VDP programs by submitting security vulnerabilities responsibly every now and then. And most recently, I was part of the Bug Bazaar Android application development team. So let's look at the agenda for today. So today the agenda is basically we'll be looking at the OWASP Mobile Top 10 Risks and the significant updates to the list. The last OWASP Top 10 was released in 2016. And since then, the latest Mobile Top 10 Risks list has some significant updates to it. So we'll look into that. What are the changes and what are the significant additions as well. So after that, we'll understand many of the risks with practical examples and scenarios. So we'll go through some demonstrations for some of the interesting vulnerabilities that are associated with some of these categories. And we'll also look at some security risks that in my opinion are not covered in OWASP Top 10, and that are also something that should be discussed when it comes to mobile security. So before we delve into the list, let's just go through like an overview of what is OWASP Mobile Security. So OWASP stands for Open Web Application Security Project. It is a community-driven group that releases a set of practices, guidelines, policies, and the know-hows regarding application security It has documentation and you can say best practices for developers as well as hackers or pen testers who will be testing the applications. So it's an important security standard that that is that is a that is not a mandate, but it is definitely good to know a standard that gives you some guidelines with respect to developing applications as well as securing those applications and penetration testing those applications. So it addresses some of the sections like authentication, authorization, mechanisms for the application, how the application should store the data storage or store the data in storage, how the application transmits or communicates with its server, and secure coding practices as well. So let's delve into the actual list right now. So this is the 2024 list. And so there are about 4 new additions to this list. And some of the categories have been modified as well. So the new additions in the list are improper credential usage, inadequate supply chain security, input-output validation, and inadequate privacy controls. And some of the categories have been renamed or slightly modified. So we'll just take a look at the comparison. That this is a picture from the official OWASP Mobile Top 10 project website. So you can see the side-to-side comparison of OWASP 2016 and OWASP 2024. So there have been, like I said, 4 new categories that have been introduced. And apart from that, there have been significant changes in the 2024 that 3 categories have been, or total 6 categories have been merged into one single category. So previously what was code tampering, reverse engineering, and client code quality, that has been moved to a singular category, and it is named insufficient binary protections. And as well as that, in insecure authentication, insecure authorization, and sorry, these two have been merged into insecure authentication authorization. It's a single category now. So yeah, 5 categories have been merged, or they have been boiled down to 2 categories now. And some categories have been just renamed, and some categories have moved. So we'll look into each of these categories one by one as we go through this slides. Yeah, before we dive into the individual risks as well, some pointers from my end here, that we'll be discussing mostly mobile application specific risks, that is the bugs that are the bugs that present themselves based on the APK or the application source code. It's like in web or API vulnerabilities. So like injection, we'll be looking at the local injection, which is the data stored in the local database that the application uses, not the data that is sent to the server. So we'll not be looking at the server specific vulnerabilities, because in my opinion, this is an area that is important for mobile application security, and the rest of the API vulnerabilities are covered in API OS top 10 and web application OS top 10 as well. So we'll stick to mobile app specific vulnerabilities. And the applications that we'll be using for demonstration, or the applications that we'll be demonstrating vulnerabilities for, are native Java apps. That means that these applications are built for Android using Java or Kotlin, which are the native languages for developing Android applications, and not any cross-platform languages or frameworks like React Native. So we'll be looking at purely Java and Kotlin apps. So the first risk here is improper credential usage. By the way, please let me know if my pace is too much. You can, if I'm going too fast, you can put it in the chat box so I can go a bit slower if my pace is too fast right now. So yeah, continuing with improper credential usage. So improper credential usage refers to the fact that many of the applications do not follow security best practices to store credentials, or to avoid storing credentials in the application source code itself, or in in the applications, local database or local data storage options, which can be shared preferences of the application or databases, or even the files that are present in the applications directory, or even in the external storage, that is the storage of the mobile phone, the phone storage. So basically, threat actors here could use like publicly available tools to decompile the application and look into the source code of the application to find out, like to look into the code. That is, we also call it reverse engineering. The decompilation is the first process, first part of that. So after decompiling the applications, especially Android applications, you will be able to look into the source code of the application, or the intermediate code of the application, that is the Smalley code, that helps you understand the logic of the application and the information that is embedded in the application. So yeah, the impact of like locating this credential is that you might be able to log into that application, or the application might be using some services for storage or some other APIs, and those keys might be embedded in the application, and these can be misused by the attackers. And we'll take a look at some hard-coded secrets embedded in mobile application. So we'll be discussing the tool that will be used. I've mentioned that whatever tools I've mentioned in the slides, this correspond to whatever tool I'll be using for the demo. So in this case, I'm just using Jadx to decompile the application and look at the Java source code of the application. So here I've already opened the application in Jadx. We are currently looking at the Bug Bazaar APK. So this is the vulnerable APK that we have developed and released recently. So after decompiling the application, you will see all the classes of the application over here. And there are also resources. There's a resources section in which whatever resources that the application will be using, like static files to store some information or some variables are used. So inside these resources, in the values section, there is a strings XML file. In this, a lot of variables are defined, or strings are defined, that the application commonly wants to use throughout the source code. So in order to just reference it, it is just defined in the strings section. So it can be referenced by the throughout the application anywhere. So this is just a straightforward like a demonstration to show that you can you can decompile the application and look into the source code, and you can just search for like common keywords like password over here, for example, and look whether you can find some interesting information from here. There are other tokens, there are possibility of tokens as well. So you can look for tokens, or in case of encryption keys or secrets, there is a secret as well embedded in the application. So in our case, just to make it more difficult, it's a string over here that's called hard-coded password, and this is the string that you can find here. And this when you look into the application, you will find that this is needed in order to log into the application. So this is one string that the what credential that is stored inside the application, and whoever decompiles the APK, they will be able to log into the application using this credential, or attempt to log into the application. So this was a hard-coded secret here. I'll just share the my phone devices screen. So I was logged in. I'll just log out of the application as of now. So this is just to demonstrate that it's a hard-coded credential. So I've just guessed the username and I'm using that password to log into the application. So I've logged into the application and it's asking me to create a passcode. I've created the passcode. It is 2121. This will also interact with this passcode activity in the for the slides. So we'll get back to the slides as of now. So before we move to the next risk, so there are some sections here in which just giving some extra uh, notes from my end about for a pen tester's perspective. So there are many API keys or tokens sometimes that are embedded in the application. Not all the tokens that you will find are sensitive or they don't have a commercial impact. So if you decompile the application, look into the source code and find any tokens or any sensitive information that you think is significant or it has an impact, you first need to find out which services uses that token and what is the impact of that token for it to be an actual security risk or vulnerability. So we'll move to the second category. This is the new category that was one of the new categories which was introduced in the 2024 OWASP. So inadequate supply chain security. So as uh, the security landscape changes, we are moving to the left more and more. That is, we are moving towards the development part, trying to address vulnerability as many vulnerabilities we can, starting from the development and build process to the release of the application, and after the release as well, pen testing the application. So this category is kind of addressing that part, about addressing the mobile application security during development, during the build phase, and whatever libraries it uses or SDKs or third-party software the application uses during the build process. That is also, it is important to analyze that before using that library to build the application or develop the application. So the attack vectors in this case are not specific to the mobile application itself. So for example, when you are pen testing an application or testing an application, this is not something that you will test for within the application itself. This comes outside the application's scope technically when the application is being developed or the platform that you are using for developing these applications. So if an attacker is able to breach into the build application or sorry, the build process of the application, they can inject malicious code or inject malware into the application and modify the code during the build process. So that is one scenario. It is mostly theoretical, but it is possible. It is an outside attack vector. The assumption is that you'll need to first be able to get access to the application's build tool or build process or whatever application or software is being used to build that application. Apart from that, an attacker can also exploit vulnerabilities in third-party software libraries that the application included. So whenever an application is developed, not 100% of that code is written by the developers themselves. So there are some, so not all of the code is developed by the developer itself or written by the developer itself. Some of the third-party libraries might be involved for certain processes, for example, encryption or implementing root detection or SSL pinning. These kind of checks or application protections have like open source libraries out there that developers often include in the code. So the impact of exploiting some of these risks can lead to data breaches. That is obviously because if you get access to the like the build of the application. Okay, I'm reading some of the chats. I will address this during the Q&A session. So most of these applications do use third-party software libraries, and of course, if for example the attacker does get access to the mobile application's code base or the build in the build process, they can it will lead to a data breach, and they can also make it so that the application's intended functionality does not work, and they can deny service or even they can take over the mobile application entirely because they have access to the build process or the application's code base. So root beer, before we go ahead, root beer is one library, for example, which is used, which is an open source library or which was used to some applications might still use it today, but it is outdated in today's date in the sense that the applications that use root beer, the mechanisms that it used to detect whether your device is rooted or not, that can be bypassed quite easily using either patching the APK, that is decompiling it into Smiley and then patching the APK, or even using tools like Frida to inject code into these libraries functions and manipulate it so that the root detection check fails. Moving on to insecure authentication and authorization. So this is also a new category, or you can say modified category. Previously, in 2016, these categories were differentiated. Authentication and authorization was a separate category. So attackers can often bypass these authentication mechanisms or authorization mechanisms, which result into account takeover. So most of these checks that can be taken over by the like the attacker, they fail because they might be implemented at the client side, which is or locally, which can be bypassed, like I said, using the runtime manipulation tools like Frida or patching the application. And even in case where the server is involved, the authentication data or authorization data is being sent to the server, the standard API and web application test cases or attacks are applicable over here. So the attacker can attempt to inject a SQL query to bypass the authentication entirely and things similar to that. So basically, the impact of these vulnerabilities is it leads to the execution of overprivileged functionality if you are able to bypass the authorization, or you are able to gain an extra privilege which is not actually given to your specific user. It can result in the theft of sensitive information as well as access to some unauthorized data and unauthorized functionality. So we'll take a look at a demo for this using by exploiting a bug in the Bug Bazaar application. So we'll use Frida in order to do this. And the technique that we'll be using is runtime manipulation. Basically, Frida is an open source dynamic instrumentation framework. That is, it's used for dynamically analyzing and manipulating the behavior of mobile applications. So you can hook or attach into certain methods or functions of the application in order to manipulate the data that is returned to that function in order to bypass certain checks. So we'll take a look at a demonstration as of now. Okay. So we are still looking into the same application, Bug Bazaar application. It's already decompiled in Jadx. Jadx is a tool that can decompile the application and give you some version of the code in Java, how it looks like. It's not an exact code, but it uses the Smiley code to represent it in Java, and you can take a look into it to analyze the application. This is a very good way to analyze the application, and it is human readable as well as it follows the syntax that you will see in Java. So it is easier to understand the process and the workflow of certain functions in the application. So we'll take a look at this now. On the left side, you can see all the packages and the classes. So in the COM package, you will see the Bug Bazaar classes. So there are different classes for UI and whatever function the application has. So let's look into this check auth class. So this check auth class, it is an activity. So before going into the code, let's get an overview of what an activity is. So in activity in an Android application is just a screen in very simple terms, it's a screen or a page inside the application. So as you can see in the application, there is a home page and then there is a profile page as well. So there is an activity, most likely there is an activity behind all of these screens. And usually if there is a UI and something is displayed on the UI, an activity is responsible for showing that data. And within Android, there is also a concept called an intent, that an intent is a messaging mechanism that activities use to pass some information from one screen to another or one activity to another. So whenever you log in, an intent will be sent to whatever the next activity is, say your home page, and it will load the home page because the user has logged in successfully. So similarly in this code, you can see that in this on create method, that means this is triggered when the activity is initially loaded, and it is looking for uh, a flag or method called is logged in. So there is a class called user auth save that is has this is logged in method. And what this if condition means is that if the user is logged in, that means if it is true, then it shows that a message that welcome back, and then it will check whether the passcode is set was set in initially or not. If it was not set, then it will load the passcode activity class and it will ask for the passcode. So basically, whenever the application is minimized and you open it again, you are asked for the just a second. Okay, so whenever the application is okay, so ideally we should get okay. So ideally, whenever the application goes to the background and it's again, you access the application, like you see in many of the applications in your phone, if they are banking apps or finance apps, or most apps that deal with transactions of some kind, they will ask you for some passcode every time you open the application. So this is a similar functionality that is implemented in this Bug Bazaar application. So it is asking for the pin passcode. We had set the passcode earlier, 2121. Okay, and when I click on the validate, it takes me to the home page. So currently it checked the passcode flag and it saw that the passcode was already set. So it has started this activity called passcode activity. So we'll look into that passcode activity. So this, you can see the passcode activity is in UI passcode activity. So there is this UI package, and inside this, there is a passcode activity class. And in this passcode activity class, we will just look into the code over here. Okay, so in the passcode activity, it is checking for whatever you can see in the on click method here. When we click on validate, it is checking for the text or the pin code that we have given, and it is comparing to this user auth dot get passcode, whatever value is written by this user auth dot get passcode method. So user auth save is another class which is being called when you click on this, when you enter the pin and you click on validate. It calls this, it gets our passcode text from the screen and it compares it with authsave.get passcode. So let's look into that now. So this is the workflow basically. We went from the check auth screen to the passcode screen or the passcode activity. and the passcode activity is calling this user.save.getPasscode method. So we'll look into that to find out what is happening over there during the validation of the pin code. So we are in the user.save class now, and in that we need to find out the getPasscode method. So you can see that the getPasscode method, it is checking the passcode, or it is retrieving the passcode from shared preferences, and it is comparing that, or it is returning that passcode to the passcode activity for comparison. And if it is correct, then it will start the next activity and allow us in. If not, it will give the incorrect passcode. So because this get passcode is retrieving a string and just returning it from shared preferences, we can try to hook into this method get passcode and return whatever passcode we want, and whatever passcode we want will be returned by this get passcode method, and the same passcode we can enter. So these two values will match, and we'll be able to bypass the pin code of their pin code activity and login. So we'll be using Frida in order to hook into this get passcode method and manipulate the return value of this method so that this matches and we are able to bypass it. So let's look into that. So I have already written this script. I'll just explain this what is happening here briefly. So as we were in this user.save class, we are using this class and using the entire path of that class, just logging some message that I am hijacking the passcode function. And then inside this passcode functions implementation, we are returning this static value 1234, this 4-digit pin. Currently the pin is set to 2121, and we are just returning this value because we'll enter this value by ourselves when we are trying to log into the application. So this is how we can subvert the logic, and the implementation is insecure here because it is locally checking the pin code, and also it is just fetching that pin code from shared preferences and passing it back to the application. So we can try to hook into this application and manipulate the return value over here. So before attempting the Frida runtime manipulation, we'll just check if we are connected to the device using ADB. So the Android debug bridge is a command line tool that is used to interact with the application using a interact with the Android device using a command line interface. So the debug bridge is not available, or it is not by default enabled in our personal devices, but I have a rooted device on which I have enabled debugging, and I can connect to the application using ADB. Sorry, the device using ADB in that manner. So we have successfully connected to the application. And now using Frida, we can check the application's package name. We will be needing that in order to hook into it and try to manipulate the method. So I'll just start the application. So it is asking us for a passcode again, right? So let's just So this is a Frida process list command. So it lists the running processes or applications on the Android device that are currently running. So we can see the identifier for our application is com.bugbazaar. we'll just try to now hook into it. So just a brief explanation of this command is that this is the identifier of the application, and we are using this script that I just showed you, and in order to inject into this application. So we'll just run this. Meanwhile, I'll keep this screen open. So as of now, if I try to enter any random passcode, it is giving me the incorrect passcode, which is the intended functionality. And let's hook into it. So it is saying that the pin code is hooked, and it started that activity again because we have hooked into that activity. So now if I try to enter my existing pin code, which I had set 2121 at the start, the validation will fail because now we are returning based on our script that we had written. We are returning this static pin code 1234 that we want, so that we are able to bypass the pin code. So now I'll enter 1234, and it says that the passcode is correct. So whenever I hooked into it and it manipulated the pin code, it said that it is inside the passcode function, which we had logged in order for us to know that we have hooked into the application correctly. So now I can navigate into the application as an authenticated user. This is just for confirmation that the bypass was successful. So this is one example of using runtime manipulation to bypass the pin code. So the vulnerability exists here because mainly this is locally, the authentication is done locally. That is, there is a shared preferences file in which the pin code is stored. So we can also take a look at that shared preferences over here. Just log into the application. Sorry, I'll log into the device using ADB. So the applications are ideally the data of the applications, whatever the application stores inside the device, it is usually stored in this path data, and the identifier the application that we had previously identified, that will be the name of the folder. Okay, so here inside there is a shared preferences folder. So here you might be able to see many XML files, and in that one of them is user-auth.xml, and you can see passcode is stored here, and that is 2121, and it is retrieving this passcode during the normal workflow of its authentication process, and we are hooking into the method and replacing it with our own string 1234, and that is how we are bypassing. So usually if there was server side validation and the pin code was sent to the server, then this would not have been a possibility, this type of exploit. Okay, so we'll go back to the slides now. So again, some notes about, like, did you know that in authentication authorization, these client side controls can be bypassed by users and applications installed on the device. So server side reinforcement of these authorization and authentication controls is critical. And in case where offline authentication or local authentication is required, the developer should implement like code integrity checks to detect any authorized code changes. So the FRIDA being able to hook into it is an attack vector now, because the authorization or authentication was done locally. So if the application checks for the tools like Frida not being able to inject or hook into the application using some integrity checks or application protection mechanisms, so this can be avoided. But in general, server side reinforcement is the intended way to implement authentication and authorization. So moving on, insufficient input and output validation. So this was also a new category that was added in this OWASP top 10 of 2024. But this is not a new type of attack. This has always been the case in web applications. These attacks have been pervasive or very common in web applications, but category has been made now. Earlier, there was no specific category for injection and cross-site scripting attacks. So basically, adequate input and output validation should be present in the application source code as the first rule of application security is that no user input should be trusted. Never trust user input. So that is the gist of this category over here, that any user input and output that is displayed on the screen, that should be validated by the application. And the impact again can some of the same things that can lead to unauthorized access to sensitive data. Like just now we were able to bypass the pin code, so we were able to get access to unauthorized data which we would not have without knowing the pin, and manipulation of app functionality and compromise of the mobile application or the system. So in this particular category, some of the tools or the technologies that are, sorry, the terminologies here are web view related attacks. So cross-site scripting attacks in mobile applications are mainly because, or not because, but if web view is present in the mobile application, only then these type of cross-site scripting attacks are possible. So what is a web view? A web view is an extension of Android applications view class that lets you display web pages in your activity. So WebView is a browser inside the application basically. So if you want to render some HTML content or a web content inside your application, then a WebView needs to be used. But of course, because it can render HTML content, user input should be validated, or arbitrary web content can be loaded inside, or unintended web content can be loaded inside the application. So we will just take a look at a video of exploit that is present for one of the bug bazaar bugs. So I'll just go to that. I'll just go through that video one by one. I hope the video is like clear for everyone. If not, please let me know in the chat. It is, right? Okay.
The video is clear.
Okay. So here right now we're just opening the bug bazaar application. We have a specific activity called terms and conditions in the application. So this loads a page from our Payatu's website over here. And this is the source code or the decompiled code of the application that we already have open here. So inside the terms and conditions activity, you can see that a web view is defined here, or a web view is used, and a string is declared called a web view URL over here. So let's just go further. So inside this web view on create, as in whenever the activity is loaded initially, so the application flow goes into this on create method. And here basically there is an if condition that is looking for some extras via this get intent method. So like I discussed earlier, or noted earlier, an intent within Android or within the context of applications is a message that one activity can send to other activity. And this message can be utilized by that activity to do whatever function they want within their activity. So here, there is a condition that is checking for this WebView URL string. And this WebView URL string is passed to this start WebView method. So we'll go a bit further for that. Just go through that. And in the start WebView method, it is just taking that string that is being passed to it via that intent as an argument, and it is loading the WebView using WebView.load URL. It is a inbuilt method of WebView of loading the URL. That means whatever string is given to it, it will load that URL. So it is assuming that the string is a URL over here. So certain properties that are implemented or enabled for WebView also can expose an additional attack surface or expose the application to additional attack vectors. So here you can see that JavaScript is enabled over here. That means that if the URL contains the URL that is being loaded contains JavaScript, that will be executed within the context of this application. So just showing the settings over here that is risky or that can lead to a vulnerability. So again, checking the intent, if it has extras, that means some string is passed in the intents. If it is not null, then it is executing that, or it is going to the next if loop. And in that if loop, it is extracting that string's value and then starting the WebView activity. So moving ahead. So moving ahead, now we are just showing the constant that has been declared over here. So the WebView that needs to be loaded is hard-coded in the application here called WebView URL over here. And the WebView URL is a string that can be passed to this activity as an intent. And there is another string called terms and conditions URL, payatu.com, which is what was loading initially when the user clicked on the terms and conditions. So just showing again that the WebView URL is being fetched and it is being loaded in the WebView. So these are the steps that have been used to identify this vulnerability and develop an exploit for it. So we checked if the WebView is implemented, it was implemented, then it had a set JavaScript enabled property that was enabled. So because of this information, you can create or figure out that you can create a file that has JavaScript, and you can load that file in this activity or that URL in this activity. And the JavaScript contained in that URL should be loaded into the application based on this. So before moving ahead, just explain this ADB command briefly. So like I said, ADB is a way for developers or anyone who wants to interact with the device from the command line. So ADB shell AM stands for Activity Manager. That means it is a component that can be used to start, stop the activities and pass intents to these activities. So here the package name is mentioned and the class, which is terms and conditions, it's the entire path of that class is mentioned. And like we noted in the code earlier, the WebView URL string has been defined over here, and that is being used or that has been fetched via an intent in this class terms and conditions activity. So this has been passed by this flag -e. It stands for extras. So we are sending an intent to this activity terms and conditions with this extra called a WebView URL, and in the codes is the actual value of that WebView URL. So that is HTTP colon whatever your server's address is, and XSS.html, which will contain the JavaScript that we want to execute. So we are just copying the path for that. And this is just the simple server which you can host locally using Python. And we will use that HTML file or host that HTML file on the server. So just checking for the IP of our system where the server is hosted. Okay, so the server is started successfully over here. Just starting the server, that's all over here. And this is the path of that XSS.html. So before going ahead, there was just some error in the URL. So the URL has been loaded successfully, and there was a JavaScript contained in that HTML file that has been loaded by this page. So this alert box signifies an alert statement in the JavaScript file. So because JavaScript was enabled, the activity loads HTML inside that and JavaScript as well. So you can see that within the application, this alert box is now present. So ideally, this particular exploit will work in a scenario where you already have another application installed on the device, which will send this intent to our vulnerable app, that is Bug Bazaar, and that will lead to this alert box or whatever JavaScript you have written in that HTML file to be rendered in the applications context, in the Bug Bazaar applications context. So in order for this exploit to be delivered, you need another application to be installed on your device in the first place for this exploit to be delivered. We'll move on to the next activities, to the next categories. So insecure communication, this is a very generic category, which basically stands or it says that communication between the application and the server should be secure. Most of the applications these days, if they are using REST APIs, that is, they are using the HTTP for communication, or they are communicating over the web, they will be ideally using HTTPS. There are still some applications that could be using like plain text or HTTP protocol to send the traffic. But most of this category is what it pertains is to that the communication should be secure. So for most generic applications on the market, only a TLS connection or a HTTPS connection with the server that suffices as secure communication. So if it is not on HTTPS, or a threat agent or an actor that is eavesdropping or sniffing can in the network can intercept and potentially modify the plain text traffic. So this is not a new vulnerability. This has always been standard best practice that the communication should be on HTTPS. The impact of this flaw, it can lead to user data that is exposed, PI that is exposed. Potentially, if any authentication data is intercepted, the attacker can even try to take over the user's account and try for further elaborate attacks. And so this is pretty straightforward that the communication is done on HTTP or a similar protocol that is plain text, then that is a example of insecure communication. So some points about that with respect to insecure communication. Did you know that many modern day applications use HTTPS for communication? Very few of them use like plain old HTTP for communication these days. So you might not come across many applications that use HTTP. But however, the caveat is that some applications use other technologies for communication, like for your smart devices or even smart bikes or smart sound systems or speakers or even your smart bulbs. So Bluetooth or NFC or other communication technologies could be used apart from Wi-Fi or internet. So these can be vulnerable to eavesdropping or sniffing. There might be certain attacks or vulnerabilities with respect to those communication methods. So that is also something that is covered in this insecure communication or comes under that. So these are a few theoretical OWASP categories, you can say, or more of category from a compliance perspective. So OWASP is a community driven uh, program. So many of the categories that are mentioned over here, they don't necessarily directly correlate with any vulnerabilities or any attacks, but they are more about the data that is transmitted and data that is stored, how it is handled, and from a compliance perspective, whether the data is handled properly by the application. So this is a new category that also is talks about things with respect to the privacy of the user. So as everyone knows, these days privacy is a pretty big deal based on the data that is being captured by many of the applications that we use day to day, sometimes even without our consent or without our knowledge. So there were many regulations, like many regulations that have been defined in EU and US. GDPR is one of those regulations. So many applications that store data in EU regions that have to comply with these GDPR regulations and data privacy and protection standards. So PII is always used as a example to when we talk about privacy. So PII contains your full name, full address, credit card information, emails, and IP addresses as well. So the category mostly like is associated with when application is being developed, PII data should be handled carefully, and only the data that is required should be stored by the application. So if you are just an application that is an e-commerce application, for example, you might not need certain information from the user. So only the application that is sorry the information that is required should be stored or handled. And the impact, like I said, this is not necessarily something that you test for. It does have a very little technical impact on the system or the application as a whole. Or the if the PI includes authentication data, then it affects the application to an extent. Apart from that, within the category, there is no specific attacks correlated with this. But any of the rest of the categories, for example, insecure authentication authorization that we saw, that can lead to the leakage of PII. So you can correlate the vulnerabilities with each other if the PII data was exposed in bypassing the application. So that is a breach of this standard or not in compliance with this standard if PII data was exposed due to any other vulnerabilities that were exploited. So moving on, insufficient binary protection. So this was one of those categories that many different categories was merged into one. So in my opinion, this clarifies the OS top 10 risks a lot, and it gives it better clarity about this particular category and what kind of risks are covered inside this category. So initially, reverse engineering and code tampering and code quality were different categories, but right now they are all part of this. So reverse engineering basically means what we did. This is basically one part of reverse engineering. If you just decompile the APK and you are able to look at the code, you are reverse engineering the application. Apart after that, whatever you do with that information, that will define the impact of reverse engineering. Whether you are able to scan or retrieve any sensitive information from the APK, whether any sensitive algorithms are exposed, even in the age of AI now or large language models. Some applications store large language models offline, and that might be like intellectual property of that company that has developed that large language model. And reverse engineering the application might lead to the discovery of that large language model and exposure of that. So that is again sensitive information there. Code tampering is basically what we are going to look into now. Basically, like I said, when you decompile the application using Jadx, you get the Java equivalent source code of that application, which is readable, and it is very good for analysis of the application. But there is another way to decompile application using some another tool called APK tool. It will decompile the application into the Smalley code, which is a form of human readable code, you can say, and an intermediate code, which is kind of like assembly language, but you can understand that much better than assembly language because it is quite readable. And you can also use it to modify the behavior of the Android app and rebuild that application. So that is what we will refer to as code tampering here. That is decompiling the application, making some changes in that application, again rebuilding that application to bypass some check or change the behavior of the application. So the impact is here that again, there are a lot of overlap between the categories, because here like leak of valuable secret or commercial API keys. So if that valuable secret is a credential or a username and password, that will be corresponding to the like the insecure use of credentials category. So that is one thing. Reverse engineering can lead to disclosure of sensitive information or API keys. And the other thing that we just talked about is code tampering. And code tampering can be used by an attacker to change how the application behaves or access some hidden features or paid features of the application, and also to bypass some protection mechanisms or security checks like root detection. So many applications have this root detection check inbuilt, which will not allow you to run that application on rooted device. So smiley patching or code tampering, uh, in the generic term, can be used to bypass detection checks. So here are some tools and terminologies listed over here. So decompilation, because we'll be decompiling the APK into Smiley codes using APK tool. We'll be looking at Jadx to get a side-by-side view of the Smiley code, so we can identify the Smiley code with respect to the Java code and identify the exact location where we need to make changes. It always helps to look at the Java source code, which is much more readable than Smiley code. And after that we'll be patching the APK. So let's get into the demo. Yeah. So there is this application that we'll be using for this demo called Smiley Changes. So just an internal application that was developed by one of our consultants for testing some smiley patching challenges. So we'll look into this challenge called modify the method. So the challenge says that in order to reveal a token, the text below should be changed to Trailblazer, and currently it is modify me. So currently you can see I cannot, there is no option for me to change the text on screen via the UI. There is this execute button. If I click on it, it says you got the wrong text. So let's just quickly look at the the Java source code of this application. I will just load it. So this is the decompiled Java source code of Payatu Smiley CTF. So there is this class called modify method, and we can see here that there is a string declared called modify me, and basically that is displayed on the screen as right now. And based on there is an on-click listener. So on-click listener is just a service that listens to the user's clicks, and based on that on-click execution, it executes some code. So there is an on-click method here, and when we execute this, or when we click on this execute, certain instructions are executed or certain lines of code are executed. So you can see here when we click this execute, it is calling this Loki Odinson method. So it is a method that is defined here, and we can see the logic in this method is that there's a if condition, and it is checking this string called text to display, and it is currently modifying me, and obviously it is not matching with the text that the developer wants it to match it with, Trailblazer. And so it does not match with this, so we will come out of this loop, and then it goes to this toast is just this a notification that you get that is called a toast, and it just says that you got a wrong text over here. So basically what we need to do is we need to figure out a way to have this UI say Trailblazer instead of modify me. And you can see that even if this condition matches, that we are able to modify this, change this variable text to display to something else called Trailblazer. And then even if this condition is equal, the very next statement is a finish method. So the finish method basically is like there are life cycles of the activity, just like on create, and finish is the one of those methods of the activity which closes the activity. So even if we just change the string, it will just close the application. So we need to do something about that, maybe try to remove that piece of code entirely. So we will get past that, and there is you can see there is this secret token text that will be displayed on the screen. So that is our goal, to display that secret token on the screen without exiting the application. So let's head into Kali in order to decompile the application. So currently we are connected with ADB to the device, and we'll download, or we will fetch the APK of the application. So you can, on Android devices, you can use ADB to pull the APK from the device. We will just go through the steps to do that. So ADB shell PS is a command which will list the current processes of the application. So we will just grep, as in we'll just look for the Smiley CTF application in the results. So this is the identifier of the Smiley application. So after that, we will look for the path of this Smiley applications package. So PM is package manager, and path stands for the path of the package. And this is the identifier using which we can fetch the path of the package. So after executing this command, we get this path in data. Like I said, applications data in Android is stored in the data or some cases data app folder as well in the APK. The APK of this application is stored here. So we can use ADB pull to pull this APK from the device onto our system. So we have successfully fetched the APK of the device. So we'll quickly go through this. We are decompiling this APK as of now to get the Smiley classes or Smiley code as we discussed. So you can see there is a lot of Smiley classes over here. We are interested in this modify method class. modify method is here. Okay, so we'll just look into that. So we'll just open the code side by side. So you can see the string text to display modify me is over here. And here in Smiley instructions, it is defined as a constant string. V0 is kind of a variable here. You can consider this to be a variable. It's a register that is being used to identify variables in Smiley, and this identifies the type of variable string. So modify me, we have to modify this to the other string trailblazer that is required to pass this check, this if condition. So we have modified that, and let's see the other code. So we are interested in the code that is written over here in this Loki Odinson class. So you can see that this method corresponds to this public void Odinson corresponds to this Loki Odinson method in Smiley. And you can see this trailblazer is defined over here again in string. And the if condition that is comparing the text to display with trailblazer here is this is the equivalent statement of this if condition. So if any means if not equal to. So if v0, which was the text to display variable, and v1 does not match, it will go to condition 0. And condition 0 here is about the displaying that toast message, you got the wrong text here. Okay. So we don't want to go into that condition 0. So we have changed the v0 value to trailblazer. So this will be equal now, and it should execute the next instructions here. But like we can see, finish is mentioned here. So in the next line over here, the finish method is called. So we don't want the activity to actually finish and close because the secret token is in the next statement. So we can just remove this line. So we remove this line, we'll save the Smiley code here, the class. So APK tool can not only decompile, but after making changes, you can also build the APK again. So we'll use this command to build the APK inside this folder. So whatever code is inside this folder, it will rebuild that into an APK. So this APK was successfully built. We'll just rename this APK to something else. So we have our Smiley patch APK now. We need to move this APK into the application, and then we'll try to run it and see if we were able to bypass the challenge over here. So before installing that, I will just uninstall the existing application from the phone. The exact path of the download folder is quite big, so I've noted it down. So we've successfully pushed that APK on the device. And Android applications, APKs. So in Android applications, APKs do not cannot be run just by moving them to the device after building APK tool. APKs need to be signed by a developer's certificate. So in order to do that, because this is a rooted device and we just want to test the challenge, we'll use an application called APK Signer, which is already installed on my device. So this is the application that we want to sign. So we have successfully signed the application and now we will just install it. We'll go to the modify method again. You can see that the text is now changed to Trailblazer, and after clicking this button, ideally, if the finish method is removed, then we should see the secret token, and we can see the secret token. Okay, so this was an example of smiley patching and which falls in this insufficient binary protections category. So let's move on to the slides. We are running a bit out of time here, so I'll just try to speed this up, the slides. So basically, insufficient binary protection, some pointers about that, or some of my takes on it is that many of the applications are vulnerable to binary attacks to some extent. So it is not something that can be patched or addressed completely by the developers, because as the category says, it is insufficient binary protection. So depending on what kind of APK it is, maybe it belongs to some financial application or some financial service, then this is more important for them to ensure that no one is able to reverse their application. And like I said, if someone has some uh, intellectual property embedded in the application, like some large language models or some AI models in that, so those kind of organizations need to be extra cautious of implementing a strong binary protection. And like apps that have sensitive data hard coded, they are particularly vulnerable to this. And basically, threat actors that want to test applications, they use runtime manipulation techniques or smiley patching techniques, like we just did for a very small change. But they can try to patch the applications to bypass some common binary protections in the applications. Apart from that, like because we saw that smiley is an intermediary language in which you can understand and modify the behavior and rebuild the APK as well. But iOS are fully compiled applications. So when you cannot decompile the application like you can do for Android applications, so they are less vulnerable in general to reverse engineering and code tampering, because of the higher level bytecode, that is the smiley code, which is found in Android applications. So apart from that, security misconfiguration, this is an existing category which has been just moved. And basically this pertains to all the Android applications, configurations and policies. So the application has many policies that are defined in the source code or configurations, and misconfiguration of these can lead to some kind of vulnerabilities or unauthorized actions on the target application. So basically, some of the examples of these security misconfigurations are exported activities, that is, activities which are not meant to be exported. So activities are pages of the application, like we discussed earlier, but most of these activities are private and they cannot be called by other applications or executed by other applications. But if the application is exported, or the activity is exported, then other applications can trigger the activity uh, from, like, another application can trigger the activity of, for example, the bug bazaar application. So some sensitive activities or activities that are not meant to be exported or not meant to be public, they should not be exported. So we'll take a look at one of those examples here. And the terminologies here, activities and intent, that we already discussed. Intent is a messaging mechanism between activities that is used. And ADB is the tool that we'll use to trigger that exported activity. So let's just take a look at that. So going back to the Bug Buzzer application, so we'll look at the source code of this application again. So specifically, we'll look at the application manifest over here. So the Android manifest is it stores the metadata of the application activities, services, and the permission that the application requires. Different types of permission regarding storage, access to the phone call logs or SMS. This type of metadata or information is stored here. Apart from that, this type of SDK or what kind of Android version it is targeting, that is defined over here. And apart from that, the activities are declared over here. Whatever activities are inside this application that are declared over here. You can see there are many activities are declared over here. So for the sake of this demonstration, we are looking at this profile activity specifically. This contains some information regarding the user. You can say PII regarding the user, personally identifiable information, their email, their full name, their email. So you can see that it is exported over here. So this is an example of a security misconfiguration. Because it is exported, you will be able to directly access this application, or even another application residing on your device might be able to call this activity, or not might be able to, it will be able to call this activity because it is exported. So as of now, we have seen that whenever we are trying to log into Bug Bazaar, or we are opening Bug Bazaar from background, when it's in a background state, it will ask for a pin. But as this my profile activity is exported, we can directly try to call this activity from ADB. So we will use the ADB shell AM activity manager in order to call this activity or trigger this activity. So the flag n is used in if you want to access or trigger any activity. So basically what we are doing using this ADB shell AM command is we are simulating another application that is installed on the device. So say there is another malicious application that is installed on the device already. It can invoke the profile activity because it is exported. So using the ADB shell command, we are simulating that process, that we are acting as a malicious application that is invoking the profile activity. So we'll just look at the path of this. Currently on the screen, we are stuck at the passcode screen as of now on the device. So the syntax for this is that the package name needs to be separated from the class name over here. So, and this is the class name or the activity name, my profile, and this is the name of the package. So we'll just try this. Okay, maybe something wrong with the syntax. Just a second. Okay, sorry. Start was missing from here. So you can see that it's starting the intent, and on the screen here, it is now in the My Profile section. So we've bypassed the pin code now, and we can freely navigate inside this application. Just a second. So we can even change some details over here. And after logging in, we can see that the changes were successful. So due to a misconfigured activity, we got a possibility to send like trigger this exported or invoke this activity and make changes in the profile information. So this is again an example of security misconfiguration and unauthorized uh, data manipulation due to that. So we'll look at another example of this as well. So like in this manifest file, there are a lot of metadata with respect to the activities and the application. So in this application, there is also backup that is allowed. So when this option is enabled in any application, right, whenever you take a backup of the application, all the data stored by the application, like we saw the pin code was stored in shared preferences, that will also be backed up by the device, and this can only be done when backup is enabled here. So we'll just take a look at the impact of this flag being enabled. This is also an example of security misconfiguration. So we have checked that the allow backup flag is enabled in Android manifest. And this is the ADB command in order to back up this file. It requires the package name and any name that you want to give to the backup file. The user is just taking the backup of the device. So the impact of this is that in case of the assumption is that the attacker has the physical device of the user, but the application's data, if backed up by the attacker, it will contain the authentication data or any other sensitive data that is stored by the application in its application directory. So this is an archive or a compressed archive that of that data that is extracted, and you can see all of this data is now available. So all of these shared preferences which contains the pin of the application is also available over here, as well as the user token. So this is the impact of that flag being enabled, and so its impact is more severe only when the application is storing some kind of authentication data in the local database or the local storages. So moving on, some of the notes over here is that did you know that in many of the applications, the main activities are usually exported or the login activity. So that is because you can like be redirected from another application or from the browser to that activity, because that is how you reach the login page. You cannot restrict the login page. That will kind of hurt their user acquisition or ease of use for the application, because the user needs to be able to be redirected to your login page of your application or your home page of your application in order to get some user traffic on your application. So that is just because any activity is exported does not mean it is a vulnerability. There should be some kind of a attack scenario that leads to some significant impact, and only then as a pen tester you can report this particular thing as a vulnerability or this bug as a vulnerability. Apart from that, exported activities are listed in the manifest, that they are not necessarily part of your package. So the application package uh, has its own activities, and some of the activities are exported from other apps. That your application might be using some other apps data, like Google's GMS, or for sending an SMS, it might have exported the SMS activity, SMS applications activity. So that doesn't mean that it is a security issue. So insecure data storage, again, there are a lot of data storage types that the application uses, from databases to shared preferences that we saw in the video as well as in the earlier demonstration of pin code bypass. So ideally storing any sensitive information in the client side or the local storage of the device in plain text form is not recommended, because in case of the attacker has physical access of the device, uh, considering root access, those data, that information can be retrieved by the attacker if it is stored in plain text. And obviously, the exploitation of insecure data storage the impact is that it can lead to sensitive information disclosure. So the techniques for this, or so the terminologies and tools for this are basically, in order to view the insecure data storage, we'll be using ADB, which we used to interact with the device earlier. And the types of data storage are shared preferences, like we saw earlier, and local databases, and even external storage of the device. So any files on the external storage of your device, the application might be using some files or writing some data to files in your external storage of the device. So we have video POC for this category. We'll just quickly take a look at that. So basically, in the Bug Bazaar application, this is a kind of a e-commerce application, and in the order section, in the search bar, there is an SQL vulnerability over here that the user is exploiting. So basically, the data stored in the local SQLi DB can be retrieved by manipulating the SQL command over here, or this SQL query. So with this query, what it does is, or one equal to one means whatever the query, it may be like select order from tables where order ID equal to so and so. But it adds this true statement to the end of the query, one equal to one, which will return all the information or all the orders from the backend. So this is stored in the local SQLi DB, and SQLi can be used to fetch that information. The impact of that is limited, because the data stored in the local SQLi will be your own data or the user's own orders that are present in that. So apart from that, the information stored in shared preferences, as we saw, it was stored, the pin code was stored in plain text in the shared preferences. So that is also not recommended. But there is a caveat for that. We will discuss about that in this slide. So Android 9 onwards, there was a restriction about which applications could make the files in their internal storage or their data directories world accessible or world readable. So earlier, it was very common for the shared preferences file of any application to be accessible by any other application. So storing sensitive information was not recommended at all in those, because any application on the device can read the shared preferences of any other application on the device. But this was restricted starting from Android 9 onwards. And again, to further protect the application data, Android 12 changes the default behavior of the ADB backup command that we saw. So when the ADB backup command is run, the application data is excluded from that backup. So when in the video that we saw, the shared preferences and the session and the database files were exported, those will not be possible to do with that command from Android 12 onwards. So insufficient cryptography, again, it is like it is similar to insufficient binary protection. That is, some financial applications or banking applications or applications that deal with healthcare or medical data of the user, personal health information of the user, might use like cryptographic uh, algorithms within the application to encrypt the data that is being stored in the application or during transmission of the application's data. So insecure cryptography can undermine the confidentiality of the sensitive information and even the integrity and authenticity if the attacker can figure out how to decrypt and manipulate the data and again re-encrypt that data. So again, vulnerabilities due to this, the impact is that it leads to the unauthorized retrieval of sensitive information from the mobile device. We can take a look at a demo for this. So we'll just load the vulnerable APK. So this insecure bank is an application, another application. It's an older application, intentionally vulnerable application that contains this crypto class. And this crypto class has a key that is hard coded in the application source code itself. And you can see the encrypt and decrypt command that using this key to encrypt the data that is being stored. So we can just take a look at this application. Just log into the application. Oh, sorry, the device using ADB. Okay, so we can go to the shared preferences over here. And in the shared preferences, you can see that there are two strings shared written in this file called the super secured password and encrypted username. So based on the information in this that we have discovered in this class, the type of the encryption that is used is AES-256. We know the modules of the encryption as well, the ciphers used in this encryption, because it is defined over here, and because of the name we know the AES 56-bit AES is used. So in this CBC type of encryption, there is another uh, variable being used to encrypt the data, that is IV bytes. So IV is an addition to the secret or the key, which is supposed to be unique and make it difficult to break the encryption. But because this is an insecure implementation over here, the developer has defined it as this zero array of bytes, which is actually null. So IV value does not matter in the calculation of this encryption. over here. So there are a lot of open source applications that you will see, you'll find in order to encrypt or decrypt data. There might be other applications, but I'm just using a web application to demonstrate this. It's just a web application that takes the encrypted data, and based on the keys and data that we set, it gives us the decrypted data. So we'll just use this one of these values and decrypt it. So this is the encrypted text. The secret key we have here is super secret key. We'll just copy it. And IV optional, and we will not mention anything because, like I said, this is a null value or a non-existent value of IV. So it does not matter. The key size is 256 because we can see it here in the code. And encryption mode is CBC. So based on this, we can try to decrypt and we can see the plain text password error. So here because of insecure implementation, even though cryptography is used in the application to encrypt the data of the application, but it can still be recovered by an attacker. So moving on, so did you know that encryption keys are frequently found to be stored insecurely in the application code, and attackers can reverse engineer and gain unauthorized access to the keys and decrypt the data like we did. So there are some Android developer secure coding practices in order to use cryptography in an application as well. It is called a key store. So that is more hardened way or secure way of using cryptography inside the application. So hard-coded keys or implementation like this in which key is hard-coded in the source code should not be the case. Okay, so moving on to the last part, other security risks. There are some emerging risks that, or commonly the risks that I have and in general pen testers come across or test for in the modern day. Some of these I have listed, and one of them is the vulnerability that arise due to deep link integrations. So deep link integrations basically are integrations in the application that are declared in the manifest basically. So we'll just load the manifest of Bug Bazaar. So again, so we can see here an activity has been defined, deep link, it's exported. And deep links have a scheme and host and path parameters or properties. So scheme is basically the protocol, host is the name of the link, and path is whatever path you want. So it is similar to like a hyperlink or a web link. But you can also give custom protocol. It does not matter whatever scheme you give, as long as the application, the code in the application is written to handle that scheme and host, that is fine. So basically, what are deep links? Deep links are the practice of embedding hyperlinks to specific content within the application. So again, it is a ease of use or for a better user experience, deep links were introduced. So clicking on a link, you might have come across scenarios in which you are using your mobile's browser to uh, go somewhere, say Amazon, and you click on the web link in the browser, and it takes you to the application. So that is done via deep links. That transition from the hyperlink to the application itself. So they are mostly used for advertising, marketing, and whether when user is directed to a specific product or a specific section within that application. And mishandling of the deep links can lead to vulnerabilities like deep link hijacking, unsafe state changing action without user confirmation, and web view vulnerabilities that we saw earlier. So in earlier, the web view vulnerability that we saw, it needed to be triggered by another malicious application present on the device. But in case of deep links, the link itself is handled by your application, and they have registered the links themselves. So you might be able to craft a link in a way that, and just the user just needs to interact or open that link in order for them to be exploited or them to fall victim of that vulnerability. So it kind of reduces the user interaction requirement in case of web view vulnerabilities. So we don't have time to take a look at of most of these vulnerabilities, but we will take a look at one of the vulnerabilities which is present in Bug Bazaar. So this type of vulnerability is unsafe state changing action without user confirmation. So basically, an action within that application can be triggered by just clicking on a deep link. So this is might have been not have been meant to that implementation of the deep link might not have meant to do that type of action, but because of how the code works and how the deep link is registered, you can abuse it to change some feature or do some state changing application sorry action within the application without the user's consent or without their authorization or confirmation. So we'll just take a look at that. So in the Bug Bazaar application, basically you can add items to a cart. So I'll just add an item to a cart over here called this Old Town Camera. Okay, and there is a deep link in the application that has this path for cart addition and this scheme BB Bug Bazaar. So we can just take a look at the deep link activity over here. So basically the code here says that it is taking a URI or a deep link from the uh, from an intent, and if that cart equals some known item that is part of like that is listed here, known product, then it will add it to the cart. Okay, so because the deep link is using this cart path and adding that cart to the item, we can craft an exploit so that when a user clicks on that exploit, the cart item is added to their cart without their knowledge or without their consent. So we'll just take a look at. So we'll just push this HTML code. Before that, we can just take a look at the HTML code. It is just an hyperlink of this form that is defined in the manifest, where the scheme is BB, the host name is Bug Bazaar, and the path is cart item. And because we looked at the code here, we know that it is getting a query parameter called item from this URL. And if the item exists, then it is sending it to the activity which adds the item to the cart. So we have crafted the link in that manner so that clicking that we should add this item to the cart. So we'll just go to, so we have this skateboard item over here. We'll push this HTML file in the download folder of the device. Okay. Okay, so this was pushed successfully over there to the device. So we opened this HTML page and it has this add to cart hyperlink. And after clicking this, if the user just clicks on this link, the application is opened and you can see the item is added to the cart here. So this is just an example of showing this vulnerability in a context of this vulnerable application. But in practical scenarios, you can imagine that some other sensitive actions can also be done. A report was released a few years ago in Periscope, that was an application associated or part of the Twitter corporate, in which the attacker had crafted a deep link so that when other users click on their crafted deep link, they automatically follow the attacker without getting that any prompt in order to follow that particular user. So that is an example of the unsafe action without confirmation from the user. There was no confirmation to the user, and the activity directly fetched the required product and added to cart without the user's confirmation. So going ahead, last part is another security risk or another developing area of protection in mobile security is runtime application protection. So as we saw in one of the demonstrations, in order to bypass the pin code, we had hooked into one of the methods of the application using Frida. And we also had seen another demonstration in which we used Smiley patching to modify the Smiley code and rebuild a new application. And we were able to bypass a feature or unlock a feature that was hidden. We were able to basically manipulate the method and rebuild that application. So in order to combat the reverse engineering and tampering, RASP, which stands for Runtime Application Protection, these kind of technologies or implementations needs to be added in modern applications that have this intellectual property in them, or for whom this is a major business logic issue or a business requirement, that no attacker should be able to reverse engineer and tamper their application. So these are there are some of the applications that, in the market that are now doing this, and it makes life difficult for the attacker, but certainly a motivated attacker can still try and bypass these technologies. But if you are not able to hook into the application itself, then it makes it difficult for you to manipulate any data or tamper any data in the application or reverse engineering the data. So in case of binary protection that we saw, even in that case, the recommendation or mainly the binary protection, it depends on obfuscating the code. So basically, when you can see the code, it is very clear cut and readable to anyone who is able to read Java over here. So in case of obfuscation or obfuscated code, where it will scramble the code and these kind of things, where you can see that URI or data or the name of the classes, they are straightforward, my profile. These will be obfuscated and it will be replaced by some random characters. So it is hard for you to decipher and analyze the functionality of the application. So the Bug Bazaar Android application has some interesting challenges that deal with this RASP type of or app protection mechanisms, where you are required to bypass some of these application protection mechanisms. So this is something that you can interested participants can look into, and this is a good security challenge for increasing your knowledge about app protection mechanisms and reverse engineering. So yeah, that's it. Basically, the impact is for this is that root detection and other implementation or controls that can be the bypasses can be evaded, and if Frida is restricted, the hooking into methods is restricted, so it will make it much more difficult for an attacker to tamper the application and do any harm to the business of the application or the intellectual property of the applications. So there are a couple of reference links for the two applications that I've used for demonstration in this session. One is the Bug Bazaar and one is Insecure Bank. You can even scan the QR code to get the link. Link is also mentioned here. I can also drop the links in the chat if needed. Yeah, it's been a long session. Apologies for the
So, guys, this session is open for Q&A. If you have any questions, you can drop it in the chat box. Akshay, till then, whatever questions were asked previously, you can go through them one by one in the chat
sure,
box.
sure. Devang asks, is there any vulnerable app to practice mobile vulnerabilities? Yeah, there are a lot of vulnerable apps actually. And I've just listed these two. I'll just go back to that slide so you guys can scan it if you want. So there are many applications. Recently, Payatu has developed one in the last quarter called Bug Bazaar. There's a lot. It has a very extensive number of challenges for client-side vulnerability specifically. There is no server involved, but RAS protection and many of the vulnerabilities that we discussed here. There are many applications. You can even start with, as a beginner, Payatu had developed about 10 years ago an application called Diva, damn insecure vulnerable application that will get you started with like if you are at a very beginner level, that will help you get started. I'll share the links for that in the chat. Uh, and the Diva application of Payatu also I'll share. So this was one of the very first applications that was available for testing. Uh, Can we get access to applications like Smile? Avinash, yeah, I will. We are in discussion to update the Bug Bazaar application. In the next release, we will try to include these Smiley challenges as well. There are existing applications in the like there are existing challenges in the application. Like for example, these protection level mechanisms. The easy level it is for like there will be a root beer root beer library test case or root beer library implemented in the Bug Bazaar application. So you can bypass it using smiley patching as well. The You can use either Frida or you can decompile application and make changes and rebuild the application. And smiley specific challenges will take your feedback and add it in the next releases. Ideally, the release should be coming soon for this quarter for the application. Yeah. Apart from that, how to bypass encryption, how to build a script. For that is a very broad question, Shubhangi. Basically, in this, you can practice these type of applications where you are able to identify the code of the application and understand the flow where the encryption is actually happening and what kind of encryption mechanism is being used. Uh, Basically, in Android applications, the main way to decrypt or be able to decrypt the encrypted data is key management is mishandled or it is not done well. So if you can find the key, then you can find the encryption mechanism and mode used, then you can definitely try to decrypt it. But there is no specific way. There are Frida scripts available as well. Some existing Frida scripts are there. For example, I think Frida. Yeah, so there are in the Frida code share, there are many such AES decryption. I think you might find a better script as well, which has a lot of common implementation of encryptions are written here, and you can just pass it. But then again, this is of no value to you in case of learn like if you want to learn how to try and decrypt this. this is a generic implementation. If the implementation is not in your application, then this will not be successful. So ideally for learning, I would say you try and practice on vulnerable apps which have some kind of encryption challenge. Is insufficient in cryptography related to cryptographic failures? I can say not. Yeah, I mean all those specific things come under that. We are talking about risks here. Not all risks will lead to any exploitable vulnerability. So yes, hash algorithms and all those things should be like up to date, and stronger hash algorithms should be used, or stronger cryptographic algorithms will be used. But like in this example that we looked at of the insecure bank application, the AES 256 is a very strong algorithm or encryption algorithm that is used. But because the algorithm is, it is available in the public, how the algorithm is implemented, or you can find it in the source code. The main vulnerability or the main part is handling the keys. If you can find the keys, then with the knowledge of the encryption mode and algorithms and the bit size, you can potentially decrypt the application. So insufficient cryptography is related to all the type of cryptographic failures, using outdated algorithms, not handling the keys properly, uh, those kind of things. Right. So the response decryption, there might be some different logic for that, Shubhangi. That is also possible. Yeah, I have also come across these kind of applications. Would using code obfuscation with R8 combined with EOL root beer be hard enough to bypass due to code obfuscation? Excesses, I'll answer your questions both. Second question, I'll answer first, Alex. The excesses in web, you don't need MITM for that. So basically, you can prove the vulnerability using ADB by passing data. Now, in our case, there was this string that need to be passed, and that string contained the URL. And it is that URL was being loaded into the application in the web view of the application in Bug Bazaar. But in other applications, it might be like, for example, like I said, deep links might be used there. So there is no need for MITM or invoking the activity. MITM is, it's not the right term for that. Invoking the activity, yeah, any other application might need to be present to invoke that activity on the device. But that is an assumption that is made quite a bit in Android pen testing, because we are looking at the security of the Android application, and its space is within its own, like it is an isolated application in the device, and any other application should not be able to interact with its activities unintentionally. So that is a valid vulnerability, even though the severity might change based on the scenario and the impact. But MITM is not required for like exploiting excesses in WebView. The first question is, would using code obfuscation combined with end of life root beer be hard enough? No, I would say no. It is it is not like root beer is quite an outdated library now. So in most cases, it is, unless it is combined with another other runtimes application security protection mechanisms, that is not recommended to just obfuscate it and use root beer. Eventually, the attacker will be able to bypass it. Okay, I think I've gone through most of the questions. The bypass script varies with the application logic, or you can use Frida scripts, Raji. There are a lot of scripts available on Frida CodeShare, and many people share Frida scripts publicly, writing blogs, and you'll just have to scour through the internet for that. But for your own application and for your own understanding, to upskill that part of your pen testing process, I would recommend that you look into the script or the logic yourself. Alex, you can look into something called RASP, which I talked about during the end of the session. So these are not just like anti-root libraries, they contain a lot of application protection mechanisms. And one of them, which is free, is called free RASP. You can look it up. So some of these free RASP session or these free RASP repositories you can find on GitHub as well. There is I think with the name free RASP, you'll find it on GitHub, and in Bug Bazaar as well. Some of these protection mechanisms has been integrated, so you can look into that. I cannot give a timeline, but there might be a walkthrough kind of a documentation of the Bug Bazaar application where we will document like how to bypass these free RASP integrations or these protections that are part of Bug Bazaar. But I don't have a timeline as of now, but it will come. In the meanwhile, you can look into Bug Bazaar, and like I said, you can also look into these libraries themselves that are present on GitHub. Free RASP is one of them, which is free. There are many other as well, but many of them are paid subscriptions or licenses. Share some root and SSL pinning bypass script, then code share. I mean, I use the same sources that you do, Aniket. As of now, there is no specific resource that I can share with you, because again, the context for your application might be different. And for pinning, there is, I mean, necessarily not, it's not just Frida that can be used to bypass pinning. It depends on the framework and what technology is being used for, what kind of pinning library or framework is being used.
I guess that's it, Akshay.
Yeah. Okay,
Thank you,
then.
Akshay,
Yeah.
for such a wonderful session, and thank you guys for being such wonderful participants. I hope you guys have a very nice weekend. Or the recording for the session would be available on our digital channels. So ensure that you are following and have subscribed to our channels as well. Thank you so much.
Thanks everyone for your participation and patience. Happy weekend.